Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 1 class. Today we're going to continue with quadratics, but we're going to actually get to the real good stuff today. We're going to learn how to graph quadratic functions, not using a table, but by using the vertex, the axis of symmetry, and the y-intercepts, okay? So I'm going to first, I know it's like, what is he doing? I'm repeating myself a lot. Yes, I am. I want to make sure that you really understand quadratics, okay? So what is the quadratic standard form? It's y equals ax squared plus bx plus c. Remember, y could be written as f of x. So it could be f of x equals ax squared plus bx plus c. Remember from the last 2 days in a row, a cannot equal 0, x cannot equal 0. These parabolas these quadratic functions give you a U-shaped graph, and these graphs are called parabolas. I'm going fast because, again, this is the third day we've seen this. The a and the b are coefficients. That means that they are being multiplied to variables. A is always attached to the x squared. B is always attached to the x. C is a number. C is a constant. It's a number all by itself. It's the y-intercept, and it has no exponents. When a is greater than 0, the graph opens upwards. Always. Period. You must always solve for y first. And if a is positive, it's going to open upwards. Always. When you solve for y, if a is negative, after you solve for y, get y by itself, if a is negative, it's going to point downwards. Period. Always. There are no exceptions here, my brothers or sisters out there in the internet world. When I solve for y, I got y by itself. If a is positive, graph points upwards. If a is negative, the graph points downwards. The c is the y-intercept. It is the y value on the y-axis when x is 0. Yesterday we learned that parabolas are symmetrical. That means that if I was to fold, the parabola in half, every single point of one side will touch every single point of the other side. It's a perfect half. That means it's symmetrical. The line that cuts the parabola into perfect halves is called the axis of symmetry, which is an invisible vertical line found by using the formula x equals negative b over 2a. Please remember it's an x equals equation, so that's why it is a vertical line. Vertical line. Okay? We also talked about the vertex yesterday a little bit, and now that we're here with the axis of symmetry, let's just review this. The vertex here, this is negative 1, comma 8. Please remember this. The axis of symmetry is equal to the x value of the vertex. So the axis of symmetry here is x equals negative 1. I don't need to do any calculations. I don't need to plug in the formula negative b over 2a if I was given a graph and I can locate the vertex. Once I have the vertex, the x value of the vertex equals the axis of symmetry. And vice versa. Once I find the axis of symmetry, I plug that x value into the function, and I find my y value for the vertex. Okay? You guys with me so far, right? This is all review still? Good? The vertex, what I just finished talking about. Remember, this messes a lot of people up. Remember, this is just f of x. And this value here is x. Why do I put negative b over 2a? Because that's the axis of symmetry. The vertex of a parabola determines the maximum or the minimum values of the function. And it's found by using the formula. Remember, the x equals negative b over 2a. That's my axis of symmetry. I take that value and I plug it into every single x of the function. That's why I have f of negative b over 2a. Negative b over 2a is the value I found for x of the axis of symmetry. Once I plug that x into every x of the function, I'm going to find a y value. That x and y value together create my vertex. So again, simply plug in the value of the axis of symmetry, which is x equals negative b over 2a, into the quadratic function and solve for y, also known as f of x. Okay? Now, we already talked about the fact that the a determines if the graph will open upwards or downwards. I want to review with you that if a is greater than 0, okay, you're going to have a minimum. Your vertex will be a minimum. If your a is less than 0, and I'm opening downwards, your vertex will be a maximum, because that is the maximum height that it can achieve. So that pretty much is everything we've done so far, roughly, in a nutshell. Let's put it all together. We also did this yesterday. I want to review it one more time. What does the graph of quadratic function y equals ax squared plus bx plus c look like? Well, what are the significant parts? Okay, you're going to have your U-shaped graph. That U-shaped graph is the parabola. That parabola gets cut into perfect half right here by this invisible line called the axis of symmetry. You find that axis of symmetry by using the formula x equals negative b over 2a. Or, if they give you the vertex, the x value of the vertex is also the axis of symmetry. The y-intercept. The y-intercept is the y value when x is 0. Now, do you notice how this blue point right here is 2 to the left of the axis of symmetry? Do you see how if you go 1 to the left, you get this point? That's why we have this axis of symmetry. It cuts it in perfect half. So if I went 1, 2 to the right, I got to go 1, 2 to the left. Does that make sense, guys? Okay, thank you. And then you have the vertex, of course. And the vertex is the axis of symmetry, the negative b over 2a, comma, the value of y when you plug in that negative b over 2a. And also, please remember that we also have the zeros. This guy and this guy, these are zeros. What are zeros? Those are the solutions. And they're also known as the x-intercepts, because they're the x value when y equals 0. That is the whole point of graphing a quadratic function, to find the zeros. So that's a good wrap up. Does anyone have any questions so far for me before we continue? Okay, now for those of you who are bored, new stuff. Let's go. How to graph a quadratic function. There are 3 steps usually. There could be a 4th step. I'm going to explain to you when you have to have a 4th step. But oh my goodness, is this easy. I want you to graph 2x squared minus 8x plus 9. First thing I want you to do is find the axis of symmetry. So x equals, in this case, negative b, so that's negative times negative 8 over 2 times a, which is 2, so that's 8 over 4. So x equals 2. Once you have that axis of symmetry, go ahead and graph it. I'm going to hit pause. All right, hopefully you had some time to write that down. Now that you have your axis of symmetry, x equals 2, you graphed the axis of symmetry here with the dashed line because it's invisible. Now we're going to find the vertex. So you're going to plug in the negative b over 2a, which is the axis of symmetry, which is 2. You already found that over here, okay? Now plug it in. Plug that 2 in to the function and find your f of negative b over 2a, or in other words, your y value. So I have 2 times 2 squared minus 8 times 2 plus 9. 2 squared is 4. 4 times 2 is 8. 8 minus 16 is negative 8. Negative 8 plus 9 is 1. Go ahead and graph your vertex. 1, 2, 1. Okay? Go ahead and do those calculations. I'm going to hit pause one more time. Make sure you got this. Okay, let's continue then. Now, step 3, find the y-intercept. Remember what I told you. The c is the y-intercept, right? The constant number. So 9, right off the bat. 0, comma 9 is your y-intercept. Mr. Morrow, why is that the y-intercept? Well, think about the definition. The y-intercept is the y value when x is 0. So if x is 0, that's 0. That's 0. What am I left with? 9. But if you know the proper format, the c is always the y-intercept, period. So go ahead and graph that, my friends. That's right here. Now, remember how I told you about the axis of symmetry, how it's the mirror image, right? So what's the mirror image of this point? If that's 2 to the left, how do I find the mirror image? 2 to the right. Very good. And now, guess what, guys? You're done. You're graphed. You're done. You're done. Now, there's a step 4 here. If needed, choose 1 or 2 x values, plug them into the equation, and solve for y. Plot the new points along with the mirror image. What am I talking about here? Let's say I wanted more points or needed more points. I could go x and y. Let's choose a value of x. Let's choose when x is 1. When x is 1, and I plug it into my formula, I'm going to have 2 times 1 squared minus 8 times 1 plus 9. That's 2 minus 8 is negative 6. Negative 6 plus 9 is 3. Guess what? 1, 3 is right there. If that's 1 to the left, where's my mirror image? 1 to the right, which is right here. Bada bing, bada boom. Now, it says here, if needed. When would it be needed? You only have to. You could do this anytime you wanted to, but to get more accurate. But have to, like you're required, you're only required when the vertex equals the y-intercept. If the vertex equals the y-intercept, you're only going to have one point on the graph. You will not have a mirror image point. And at that point, you have to make a table for just one value of x. Once you find that one value of x like we did over here, which I'm going to mark in red, you find the mirror image. 1 to the left was the red point, so the mirror image, 1 to the right. Does that make sense, my brothers? Pretty simple, right? When you really think about it. So let's practice. Okay, let's graph. First things first, axis of symmetry. So my x will equal, in this case, negative b over 2a. Yes, it's not always going to be pretty. So that's negative 9 halves. Negative 9 halves is negative 4.5. So I'm going to go ahead and graph my axis of symmetry. Negative 1, 2, 3, 4.5. So it's roughly there. Is this 100% accurate? But will it work for our tests and quizzes? Yes, because I labeled it. My vertex, this is the challenge for a lot of people because it's involving fractions. So the vertex is going to be negative 9 halves, comma. Now I got to make a calculation here, guys. So I'm going to have negative 9 halves squared plus 9 times negative 9 halves plus, I'm sorry, look at what I just did there. I gotta, and this is wrong. All of this is wrong. This is a great mistake that I made because I'm in such a hurry to just get the problem done. I did not take the time to read. You must always put these quadratic functions into standard form. What is the standard form of this equation? Very good. I so am sorry, but at the same time, I'm not. This is what happens when you do like Mr. Morrow did and not pay attention. You don't pay attention like I just finished doing because I'm too busy trying to focus on, oh, get it done, and I didn't take my time to read. So I apologize. Don't make the same mistake I made. So now that it's in standard form, let's do it the right way. X equals negative b over 2a. That's a lot easier. X equals negative 4. Now, you will have them ugly sometimes. So please work on your fractions. So this vertex is wrong. I mean, axis of symmetry, so it's negative 4. 2, 3, 4. It's my axis. My vertex. My vertex is negative 4, comma. We got to figure it out. We got to plug it in. So this is going to be x squared, which is negative 4 squared, plus 8 times negative 4 plus 9. Negative 4 squared is 16. 16 minus 32 is negative 16. Negative 16 plus 9 is negative 7. Go ahead and graph the vertex. That's negative 4, negative 7. That's my vertex. What is my y-intercept here? What's the c value, guys? No, what's the c value here, guys? Negative 7. That's not the y-intercept. That's not the c value. It's that, brother. 0, 9. So that's here. Okay, that's 4 to the right of the axis. What's the mirror image? So go 1, 2, 3, 4 to the left. Guess what? Do I need a fourth? Do I need to make a table at this point? Do I need an extra point if needed? No, because you have perfect symmetry. Thank you. Well put. Does that make sense, my brothers? You promise. Some of you have eyes like you're a little confused. Please talk to me. I want to make sure you got this really, really well. You understand it. So again, when is the extra point needed, Mr. Morrow? When the vertex equals the y-intercept. That's the only time you would have to do that. The only time. In fact, let me do one right now. Let's say I tell you graph y equals 3x squared minus 6. Okay? What's my axis of symmetry here? X equals negative b over 2a, right? Remember, my a is 3. What does b equal? No? 0. There is no x value here, guys. What's my c value? Negative 6. Thank you. So my axis of symmetry here is 0 over 2 times 3, so x equals 0. That's my axis of symmetry. Okay? So my axis of symmetry is x equals 0, which is right on the y-axis. Is everyone with me? Okay. Now, my vertex. My vertex would be my axis of symmetry value 0, comma, this value, the value of y when I plug it in. So it's going to be 3 times 0 squared. Very good. Thank you. Which is negative 6. So 0, negative 6. 1, 2, 3, 4, 5, 6. Now, what's my y-intercept? What's my y-intercept? Remember, it's the c value, guys. So yeah, it's 0, negative 6. Wait a second. Isn't the vertex and the y-intercept, aren't they equal? Okay, so I don't have enough points here, do I? This is when you have to do just one test point, okay? So if we do one test point to 3x squared minus 6, y equals 3x squared minus 6, choose any value of x that you want. What value do you want of x? 1. I would do 1 as well. 3 minus 6 is negative 3. So here's the beauty. You have 1, negative 3. That's 1 to the right of the axis. So what's the mirror image? 1 to the left. Bing, bang, boom. I am done. Does that make sense, my brothers? And do you understand now, hopefully, when you need the extra point? Any questions on this? Because I still have time, but I still have to do some more. Okay? We'll move forward. Thank you. Okay, now, consider the function f of x equals x squared minus 4x plus 9. Does this function have a max or a min? It has a minimum. Why? Very good. Because a is greater than 0, it opens upwards, and when it opens upwards, it will be a minimum. Now, what if I tell you, what is the minimum value? What is the minimum value? That's B. How do you find the minimum value? Find the vertex, and then the y value of the vertex is the minimum value. So in order to find the minimum value, we first have to, one, find the axis of symmetry. The axis is x equals negative b over 2a. So that's x equals 2. My vertex, which in this case would be a minimum, is my x value, 2. Plug it in. 2 squared minus 4 times 2 plus 9. 2 squared is 4. 4 minus 8 is negative 4. Negative 4 plus 9 is 5. So what is my minimum value? No. What is my minimum value? 5. Remember, the vertex is the xy, but the value of the minimum or the maximum always belongs to the y. I got plenty of time. Any other questions here, my friends? Okay, thank you very much. I think we're done. Let me just make sure. Yep, great class. Thank you very much. Hope you learned a lot. Have a great day.